Unit 2, Transformations, Lesson 2, Reflections. Your objectives for this lesson are to describe transformations as functions and to draw reflections, as well as to use geometric descriptions of rigid motions to transform figures and predict the effect of a given rigid motion on a given figure. Okay, so the definition of reflection is a transformation that moves points by flipping them over a line called the line of reflection. You can think of this like looking in the mirror, you see your reflection. So you standing outside, looking at the mirror, you are the pre-image. This line of reflection here, line K, is the line of reflection, would be your mirror. And the image is your reflection looking back at you. Okay. And a reflection is one type of rigid transformation. So we talked about rigid transformations. They don't change size or shape. So when you're looking at your reflection, you look like yourself. You don't look like, a shorter, messed up version of yourself, unless you're looking into Funhouse Mirror, but that's not a true reflection. Another word that you might hear instead of rigid transformation is isometry. So a rigid motion or a rigid transformation is the same thing as an isometry, and a reflection is one type of an isometry. Example 1 and example 2 we're actually going to take care of in class. These are drawing reflections, not in the coordinate plane. So we're going to do these in class. But we're going to skip ahead to drawing reflections in a coordinate plane. So these are your rules for reflections in a coordinate plane. You see your coordinate notation over here. So a reflection across the x-axis, xy is mapped to x negative y. A reflection across the y-axis, xy is mapped to negative x comma y. And a reflection across the line y equals x, xy is mapped to y comma x. These are rules that you do need to memorize. But I'll show you how to reason your way through it in case you forget. So example 3, reflect the image across the y-axis. I'm going to start by writing out my rule. So I know that xy becomes negative x, y. And then I'm going to find each of these points. So I'm looking at my vertices. I have 5 of them. This is at 0, 8. This is at 9, 8, 7, negative 6, 4, negative 4, 0, and negative 6, 1, 2, 3, 4, 5, negative 6, 0, negative 4. Okay. So I'm going to just start at the top and work my way around. I have 0, 8, and I know that I'm going to change the x value so that 0 would become a negative 0, but that's still a 0. And then the y value stays the same. So really, my pre-image and image here are the same. Let me move this stuff over. Yeah. Okay. Now, negative 6, comma 4. Again, my x value is going to change its sign, so that's a 6. The y value stays the same, 4. So I have a new point at 6, comma 4. 10, 9, 8, 7, 6. Okay. -4, 0. We change the x value sign, keep the y the same. So 4, 0. -6, -6. I already know from up here that my -6 becomes a +6, and the y value stays the same. So it's here. And right here, this one is also on my line of reflection. Whenever a point is on the line of reflection, the pre-image and the image are the same. So I'm not even going to work that one out. I'm going to connect my dots, and this is what I'm left with. Reflect the image across the x-axis. My rule here is x comma y becomes x negative y. So the x stays the same, the y value changes its sign. And just like last time, I'm going to start off by labeling my vertices here. So this is -6, 0, -3, 6, 1, 6, and 5, 0. Okay. So I have -6, 0, which the x value is going to stay the same, so -6. The y value stays the same. And again, my line of reflection is right here. So since this is on the line of reflection, I could have just put the point there anyway. I can do the same for this one here. So those two are going to be themselves. -3, 6. The x value stays the same. The y value changes signs. 1, 6. X stays the same. Y changes signs. So I have a point then at -3, -6. So 1, 2, 3, 4, 5, 6. And a point at 1, -6. And I connect the dots, and here's our picture. Reflect the image across the line y equals x. So this one I'm actually going to draw in my line of reflection first. That's not it. Here we go. Okay, so here's the line y equals x. And remember our rule for this one, your x and y's switch. So xy becomes y comma x. So right here I have the point 2, 4. I have -2, 8. -8, 4. And -8, 2, 4, -5. Okay. So -2, 4. Wait, that's not a point. 2, 4. X and y switch. I get 4, 2. -2, 8. X and y switch. We get 8, -2. -8, 4. 4, -8. -8, -5. -5, -8. Okay, let's plot these new points over here. So 4, 2, 8, -2, 4, negative 8, and negative 5. So 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8 right here. Okay. There we go. Connect these points. This is actually in the wrong spot. This should be down here. Okay, that looks better. Okay. Good. So this is our reflection. Okay. Next, example 4, we're going to look at some different lines of reflection other than y equals x, the x and y axis. So these are a little bit more reasoning, but you can do it. So first we're going to reflect this image across the line y equals 3. And what I want to do first is actually draw in the line y equals 3. So you know this is the y-axis, this is the x-axis. I'm going to go up 1, 2, 3. This is where y equals 3. So I'm going to draw in a horizontal line. I'm actually going to make it a dotted line. And this is our line of reflection. Okay, so remember, if a point is on the line of reflection, then the pre-image and the image are the same. So I know that those two are going to be the same. And now I'm going to look at my other points here and here. And I'm going to start with this one. I see that my point is at 1, 4. And 1, 4 is actually 1 unit above my line y equals 3. So I want to draw another line, another point that is 1 unit below y equals 3. So that's right here. This is at 2, 4, not 2, 4, 1, 3. Oh gosh. 1, not 1, 3, 1, 2. 1, 2, okay. And this point up here is at negative 1, 7. And this is 1, 2, 3, 4 units above my line y equals 3. So I want to keep my x the same and go 1, 2, 3, 4 units below that line. So I have a point at negative 1, negative 1. Now all I have to do is connect the dots. And this is my reflection right here. Okay. Now I want to reflect my image across the line x equals negative 2. So that line is here. Again, I'm going to make it a dotted line. And I know this is where x is negative 2 because if I look at my number line, I can count back and we have a negative 2. Just like last time, I want to label my vertices, figure out where we are. So this is 1, 1, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 5, and 5, 2. Okay. So I'm going to start up at the top. This point, 1, 6, is 1, 2, 3 units from my line. So the reflection is also going to be 1, 2, 3 units from the line, but the same y coordinate. Down here, this is also 3 units from the line, so I'm going to be 3 units on the other side of the line. 5, 5 is 1, 2, 3, 4, 5, 6, 7 units from my line. So I want to go 1, 2, 3, 4, 5, 6, 7 units from the line. I see that these both have an x of 5, which means they both have a reflected x of negative 9. So I'm just going to line up those points. Once I have my new points plotted, my new vertices, I can connect them, and I have my reflection. So that is all for lesson 2 on reflections. Like I said, we'll do some more constructions during class, but this is reflecting in the coordinate plane.